Earth's albedo is the measure of how much solar radiation is reflected from Earth's surface. The balance between the amount of solar radiation reflected and absorbed by Earth's surface plays an important role in regulating global temperature. When light from the sun strikes Earth's surface, some of the energy is absorbed as heat and some is reflected back into space. The darker the object, the more radiation is absorbed. The fraction of radiation that is reflected back into space is known as albedo. This animation shows how polar ice reflects light from the sun. As this ice begins to melt, from warmer air and water temperatures for instance, less sunlight gets reflected into space. The sunlight is instead absorbed into the oceans and land, raising the overall temperature and fueling further melting of the surrounding ice. What happens when you add dark-colored black carbon or soot from pollution? After traveling from its sources, often thousands of miles away on air currents, it settles onto land and into the oceans. On ice and snow, soot darkens these normally bright surfaces. Instead of reflecting the sunlight, this darkened surface now absorbs more of the sun's radiation. Moreover, as glaciers and ice sheets melt, they tend to get even dirtier as the soot becomes more concentrated, speeding up the process of melting. This animation shows how soot-darkened ice retains more heat, lowers the albedo, and tends to increase melting. Scientists using satellite data have confirmed that the amount of sea ice that floats in the chilly Arctic has declined significantly. The average yearly decline since 1979 is 72,000 square kilometers, which amounts to more than 10% per decade. The vast stretches of polar ice covering much of the planet's top and bottom reflect large amounts of solar radiation falling on the planet's surface, helping regulate Earth's temperature. This animation shows how melting ice on land and at sea can affect the surrounding ocean water, changing both the temperature and relative sea level.